Fossils are the remains of things that were once alive. Scattered across every continent, they teach us about the history of the Earth and provide evidence supporting the evolution of life. But finding a fossil isn't easy. As paleontologist Robert Bakker explains, it requires a trained eye.
The most important thing to look for when you're out digging dinosaurs is the stuff over there, in the periphery of your vision. So when you're digging dinosaurs, you've got to have a sort of a 360-degree ecological vision. Look at everything. Be aware of everything.
Paleontologists travel through deserts, frozen tundra, oceans, and underground caves to uncover the remains of ancient and extinct species. The job can be risky, yet finding a fossil is only the beginning. Once it's discovered, paleontologists must carefully extract it from the ground. This excavation process can take days.
Put over there. So here's the other nostril right here. Yeah. I'm digging in the nose.
They must be cautious not to damage any remains. Once removed from the ground, the fossil is wrapped in aluminum foil and plastered burlap to keep it safe during travel. In the lab, the wrap is removed and the fossil gets a thorough cleaning. The original fossil is too heavy and fragile to display, so scientists make a reproduction. They brush rubber on the outside of the fossil to form a mold. The hardened mold is removed and filled with resin to make a copy of the original fossil. At this stage, paleontologists also create models of the missing parts. As Dr. Paul Serino explains, they make the most out of what they have.
We had enough to wish we had more. We had enough to say we could take this and make a skeleton out of it. We hunted for that skull. We wanted the skull. We didn't have it, but we had enough of the animal, the limbs, and enough of the backbone to judge its size correctly and to get a picture of what was a very agile animal.
The reconstructed bones are now ready to piece together. They're placed onto a steel frame that provides support. The shape of the frame gives the completed skeleton the appearance of motion. Putting together a full skeleton is a tremendous challenge. With pieces missing and sometimes only fragments of a bone to work with, mistakes are not uncommon.
Well, my mother sometimes rattles my cage by saying, well, Bob, you scientists, you always make things up. You get a single bone, you build a whole animal, you got the wrong head, the wrong tail, tail on the wrong end, head on the wrong end. That does happen on occasion. But almost always it's another scientist another anatomist who catches the mistake and corrects it.
In most cases, paleontologists eventually get it right. With a lot of skill and a little bit of luck, the results are extraordinary. The resurrection of a species that became extinct millions of years ago. On a Caribbean island, scientists are hoping to uncover secrets of a prehistoric world. They traveled to the Dominican Republic in search of amber, a semi-precious gem that originates in trees. More than a gem, amber preserves life from the distant past. It starts as a sap-like resin that trees expel to protect themselves from disease. As the resin flows, things often get stuck inside. It takes just seconds for flowing resin to trap and preserve its victim. Trees die over time, and their limbs often end up in the water. In this river, chunks of resin fall off and sink to the bottom. Silt and mud bury the pieces, and over millions of years, the immense pressure hardens them into gems. As tectonic plates collide, the Earth shifts and buckles. layers of ground get pushed up into mountains, carrying the amber with them. Today, paleontologists follow trails of ancient marine rock in search of fossils found in amber. Along the mountains, they work in shafts driven deep into the ground. The heat, humidity, and unstable soil make their job dangerous and uncomfortable. But the payoff can be great.
Roy, Manuel, how are you? What'd you get, Roy?
I think we got something special.
Some of the pieces reach David Grimaldi at the American Museum of Natural History in New York City. Using both light and scanning electron microscopes, he studies what lies within them.
Technology has revealed a level of preservation that was unexpected. Soft tissues, things like muscles and organs are intact in these things. They're dried out, but it's beautifully embalmed. I mean, ancient Egyptian morticians would have been envious of this kind of embalming.
Unlike fossils buried in the ground, fossils in amber are often perfectly preserved. This gecko struggled to stay alive as the resin engulfed it. X-ray images reveal that its spine broke in several places. This caterpillar is one of only a handful of its kind ever found. It probably lived in the same forest and ate the same plants as the dinosaurs did 120 million years ago. Here's a very old flower from an oak-like tree. It marks the time when flowering plants began to spread over the earth. Fossils like these help paleontologists understand ancient worlds. But they could be useful to scientists in another way. Grimaldi looks inside the amber for fossilized tissues and cells. Enlarged 20,000 times, this is the spongy brain tissue of an extinct being. In this image, clumps of pollen from a mysterious plant are even more defined. If individual cells can survive, might these samples also hold the DNA of a creature from long ago? Grimaldi and other scientists are attempting to extract dinosaur DNA from the fossils in amber. But for now, cloning dinosaurs remains the stuff of movies, like Jurassic Park. There are so many secrets waiting to be unlocked inside this beautiful and mysterious gem. Some people call it Rhino Pompeii. Like the ancient Roman city, the Ashfall fossil beds in northeastern Nebraska capture a moment in time. They contain hundreds of fossilized rhinos suspended under a blanket of volcanic ash. In 1971, paleontologist Mike Voorhees was searching for fossils when he made a startling discovery.
I came across a ravine that led to a volcanic ash bed perched high up on the wall, and I crawled up and saw, to my surprise, a lower jaw of a baby rhinoceros sticking out of the bottom of this volcanic ash bed. I could see the tips of the upper teeth and figured that there was probably an entire skull there.
It was the find of a lifetime. Today, these fossils allow people to peek back in evolutionary time. They tell us more about the history of an animal now on the verge of extinction.
I'm standing at the bottom of what was a water hole 10 million years ago, which got filled with volcanic ash from a distant volcano and snuffed out the lives of hundreds of animals, including the rhinoceroses that we see in front of us here. Each of these skeletons tells a story of life and death on the North American savanna.
Rhinoceroses that inhabited the plains came to the watering holes in herds to drink and eat. But that all ended when a huge volcano in what is now Idaho spewed ash for miles around. The deadly ash buried the animals so quickly that their entire skeletons remained intact. Unlike most fossil deposits of scattered bones, these fossils are lifelike and chilling. One rare fossil still carries the bones of her unborn calf. Grass seeds and leaves in her stomach and mouth tell scientists about her last meal.
We're doing our autopsy on this skeleton and found some unborn bones, very thin bones of cartilage between the last rib and the pelvis of this rhino. So we know for sure that it was pregnant. When we got to the skull, it turns out that she was a very young adult. Probably this was her first calf. We know she's young because her teeth are very unworn, and the wisdom teeth are not quite out of the jaw.
Paleontologists continue to search for skeletons buried in the area.
To a paleontologist, this is an amazingly interesting place to work. We're just scratching the surface here. The skeletons that we see before us in this building are less than 1% of the total fossil deposit. So I'm looking forward to finding out what is around the next bend of the waterhole.